So you don't have to just stick with the practice test. It could be from homework, it could be from the quiz, it could be from anything. Yes?
Go over 5 from the practice test.
Sure. I gave all my blanks away, so let's see. Oh yeah, 5 was probably one of the freakier ones on there. So you see how I give it to you as a rate of savings. So that is the purpose of an integral is to take a rate and change it into a total amount. That's one fundamental purpose of an integral. In the physical sciences, you very often have information about how quickly something's flowing in or out. It could even be business, it could be money related. And I want to convert that into a total amount of water flowing over a waterfall or cash flowing in or out of a business. So in this case, I have a rate of savings, which was, let me see if I can remember. Was it 200E?
200E to the 0.1t.
Okay, good. And the first part was just to write an expression relating the amount of savings after t years. So it kind of makes sense after no time has passed. Now, after no time has passed, how much money has this kind of saved? Yeah, so watch. So if I want to know how much money I've saved after t years, that means, of course, where does it start? At 0, when I first install the stuff, right? So I'm going to integrate from 0 years up to t years. Or does it say x? I can't remember. Oh, this was 200e to the 0.1x, right?
No,
It's t?
Yeah.
And I said t years or x years?
T.
Oh, I'm so evil. All right.
Yeah.
So this is one of them's got to be x. You can't have the inner variable the same as your limit variable. I thought I was. I guess I wasn't. So if I integrate this from 0 to t, it will represent the amount of savings. So at t equals 0 years, 0 to 0 interval is going to be 0, no matter what's inside, right? So in terms of this is the total amount of savings, that makes sense so far. But let me say this again. So if t is 0, that means no time has gone by. I should have saved no money yet, right? So sure enough, 0 to 0 integral of anything is 0. Got no area if you don't have any width. All right. But if I integrate this up to just t, I'm going to end up with an expression that represents how much money if somebody tells me how much time has gone by. T will be my answer. So if I integrate this, now here's where you got to realize what's going to happen. 200, if I integrate this, the 200 doesn't mean shit. I can take it out if I wanted to. Integral of e to anything, any linear power should be that, but what do I have to take care of? I'm going to have to do u sub here. If I take this derivative, that would want to pop out. It isn't here, so I have to divide by it. In fact, you can make this a rule if you want to. E to the x, if you integrate that, you get e to the ax over a. Because whatever the hell that is, you got to kill it because it's not there. Okay, I like it. Evaluate it from 0 to t. So you get 2,000 e to the 0.1 t minus 2,000 e to the 0. So that's where 2,000 e to the 0.1 t minus 1. I'm sorry. Yeah, that's it. So now so part A was to set this up, and part B was to figure out how long until he saves $1,500. So this is the rate of savings. This is the amount of savings. So if you want to see how long until he saves $1,500, you just take this and set it equal to $1,500. So part B would be just set this equal to $1,500. Solve for t. So I got roughly 6 years, I think. No, yes.
Can you explain again how you got the -1?
Oh, just taking the 2,000 out. Are you cool with this? That's just plugging a 0 in, right? And e to the 0 is 1, so if I took a 2,000 out, I don't know why I wanted to do that, but just to show you what I did on the key. Here it's easier to have it out so you can add it and then divide and then natural log it. Right, keep on going. Cool. But I like this problem because it shows you integration compiles flow rate. If I know that there's 300 gallons of water going over some waterfall, well, how much total water has fallen in a couple of years? I can use an interval to do it. Okay. Anything else? Is that cool? Anything else? From there or from homework?
Number 7 on the practice test.
Another ants. Oh yeah. Okay. So I think it started off as first off, what is the F-talk 1? And it doesn't stand for F this old calculus. I think as a student I might have come up with that, but it doesn't stand for that. F-talk 1 is when you have integral a to x f of t dt, and you take its derivative, you end up with f of x. Now, if I do something simple like this, do you see how I've replaced x with x squared? So I've put x squared into this function. That, of course, implies what rule do I have to use? Of a function inside of a function chain rule. So it's going to be the same rule to start with as chain rule always is. What's the first step in doing the derivative of sine of natural log of tangent of x? Cosine of natural log of tangent of x times the derivative of the inside shit, which is the hard part. But the first step is just do the rule. What would you normally do? I normally would just put this there. All right, well then do it. But then you got to multiply by 2x. Okay, that's involved here too, right? Because that's an x squared. The other thing to remember is how does, what would I do here? What would I do here first? Because that's the rule doesn't have that the format. I've got to make it match the rule before I can use it. So yeah, I would make it negative and switch the limit so that it's in the right form. All right, so I did a couple of those things, right? First I flipped this, that's why it's got a negative with the stuff in the right order. Yes?
Now you negative f of x after that then?
Yeah, it'll be negative whatever this becomes, exactly. I like it. So the one on the practice test says integral x squared to 5, right? Square root of t secant t, is that it? Am I remembering that right?
Yes. T secant.
Ah, okay.
Square root T.
Now, when you are differentiating an integral, this function on the inside does not matter worth shit. It's going to stay the same. It's sort of like if I cube roots, if I said do this by hand, so far that looks disgusting, but if I do this, you're like, okay, I can do that by hand. Pop. So, derivative and integral should kill each other. So the inside doesn't truly change. It just gets evaluated at the variable side, right? Okay, so it's very similar what's going on. So I had to do this first to switch it so it's in the right form to use the rule. And now I could use the rule. Plug that in and then multiply by, I did that of course because square root of x squared is absolute value of x. You left that off, I don't know. Oh yeah, times the derivative of the inside, 2x. So then I just brought that up. Is that decent? So again, I know you guys think this is a whole new thing. That is a function of x, is what this is. So I should be able to take its derivative like any other function of x. This is an integral function of x, so its derivative should actually be easy in some respects, because the derivative undoes an integral. The inside stays the same all the way through. I just evaluated at the variable part of that. So just like we have like the derivative rule for ln of x, we have a derivative rule for integral of something with x in one of the limits. That's just there's a rule for it. Maybe that's f-talk 1. Anything else from there? Who remembers real quick, based on, related to this, what do you do if you have integral sine x to natural log of x of t to the natural log of tangent of t to the pi power? And you got to take its derivative.
You have to split it up.
Good. So you pick, you pretend like you know that A is between sine x and ln x. Oh God, Jeff, why do you have to make it something so long? Plus integral A to ln x. This has got to start to be just an automatic. That links to that. I kind of think of it in my head like they're magnets that go, and then make one big integral from that to that, which is what it's supposed to be. So those are the same. But now they both look like the rule, except this guy just has to be turned around, right? So you make them the negative. Okay, good. You're trying to take what you're given and put it in the form of the rule. It's really the same thing as before you learn quotient rule, we could do this shit here. Right? We could do that. It's just not in the form of the rule that we knew then, so we had to break it up and put it in the form of the rule that we knew when we only knew x to the n. So here, we're trying to put that in the form of the rule that we know. That's it. Okay. Anything else from anything else? Somebody in their head is right now going, just let me leave, just let me leave. I don't want to stand up right now. Now you're thinking about apple pie or something. That's what I'm thinking about. I was talking with my students about pie this morning. It's like, I need me some apple pie.
So the stuff that we just did today, that's going to be on the test tomorrow?
Oh yeah, you're crazy. Yes?
Just in terms of grading, do you think you'll have, because the tests are like 2 days apart, the third one and the final?
I have to, so I will make it happen.
Okay.
Yeah, I have to have the tests graded by Wednesday, so you have them to correct if you want and have time to. Which in the summer is always a part of the thing to think about. Do I want or do I have time to do that shit? So yes, they will be definitely finished by Wednesday. Yeah. Yes?
We can turn our remaining homework on the day of the final, right?
Of course. Why not?
How much partial credit is that?
I don't know. It depends on how much it is and how late it is. I'll tell you this, I don't know if I've told you this yet, but I never let homework fail somebody. So if I calculate your grade without including the homework grade and you passed, you passed. Because homework, if you're not doing it, it already hurts you. Why would I let it hurt you more? Right? It's like, leave her alone. No. Do you understand what I'm saying? I will let it take your grade down all day long. Oh shit, yeah. So if you did no homework and you're expecting an A, you're probably not going to get no freaking A. But I don't let it fail you. All right. I also allow you to miss about 3 homework assignments total. I let you miss 3 assignments before I start to take your grade down. Does that make sense? So if you have like 6 ones with half credit, that's 3 missing, which means you have 100 homework overall. Some of you guys are like, sounds like a great place to be, Jeff. But my bottom line is everything I do is to try to trick people into doing what they need to do to get ready for the test, because that's the heaviest weighted thing. I don't let homework over hurt people, because it already hurts you when you don't do it. I made it worth nothing one year, and that's never going to happen again, because nobody did. Yes?
And how will we know our grade after the day of the final?
You can email me if it takes too long for WebAdvisor to update. You better believe I'm going to have those finals graded grades in quick, so I can enjoy the little bit of time I have before fall starts. Trust me, man. When this class is over, I'm still working because there's anyway. You know. What else do I want to tell you? Tomorrow I'm going to have the practice final. On Wednesday I'll have an answer key for that. In all my spare time, I'll make that. Hopefully I have one on file, so that'd be awesome. Yeah, I think that's about it. So as always, I'll be in my office an hour before class starts. If you want to utilize that. My colleagues, for some reason, when they leave, they don't check with people anymore, and they just lock the door. So my God, just not hard. If I'm supposed to be in there, I am in there. I just don't know if somebody locked the door. I'm sorry. It's like 2, 4, 6, 8 of us in there, so.
Sweet.
I almost killed somebody.